All right, this is Math 209, week 5, and we are going to be talking about log functions. And really, this is going to be an exercise in Desmos this entire video, because that's going to be the tool that is going to make it or break it. So real quickly, when you have a log function like this, all right, basically what log means, like if I were to say log of 1,000. All right. So first off, when it just says log, you're supposed to think of the number 10, tiny little 10. It says log base 10 is how we actually say it. And really what this is saying, is 10, because that says 10, raised to what power equals 1,000. And that's what that means. 10 raised to what power equals 1,000? And in this case, the answer, of course, is 3. All right. But because of calculators and the fact that we have Desmos, really all we have to do is go in to Desmos, type in log 10 raised to the 13th power, and you'll get the answer of 13. Notice that there is no y equals. You just type in log. All right, and that's going to give you an answer. It's just like a calculator. So Desmos is really kind of cool. And basically, when you have log of 10 to the 13th power, that's basically saying, and there's a 10 here, it's basically saying 10 raised to what power is equal to 10 to the 13th power. And so this 10 to the 13th power goes right here. And so it's saying 10 raised to what power equals 10 to the 13th power. And so that's why the answer is 13, because 10 raised to the 13th power is equal to 10 to the 13th power. But Desmos is doing the work for us. I'm just kind of giving you a little bit of an explanation, but we're going to let Desmos do a lot of the work here. So here again, so you're just going to take your log function and you're going to type it into Desmos, and you'll notice sometimes you have to put in parentheses to make things work for you, and our answer is -3. Now why does that work? Well, because basically this is saying log 10 to the -3, so that's saying it's a base 10 right there, because if you don't have a number, it's got to be a 10. So that's basically saying 10 raised to what power is equal to 10 to the -3. And this 10 to the -3 is what goes right there. Well, that means the missing value is -3, but Desmos tells us that. And so here, again, we're just going to write this into Desmos. Now, the idea is that the trick is to know that 1 over 100 is really the same thing as 10 to the -2. So now you should be able to see that log of 10 to the -2. Well, we know that that's going to be a 10. So this is saying 10 raised to what power is equal to 10 to the -2, because this thing goes right there. And so the answer is -2. But if we wanted to, we could look at our Desmos, and sure enough, I type it into Desmos, and I get the answer of -2. And so we didn't really have to do all of this logic right here, because Desmos did the thinking for us. And even when you have some funky things like decimals in your exponent, but by now you should be starting to see the pattern, that the answer is probably going to be 14.2. And so when we type it into Desmos, sure enough, the answer is 14.2. Remember, you do not need to type in the letter y, as in y equals. No, you don't need that. You just type in log and then go. Keeping in mind, you probably have to put in parentheses to make things work for Desmos. Huge one. Now, the idea here is to know that log of 100, 100 billion could be written as 10 to the 11th, 9, 10, 11, yeah, 10 to the 11th power. And so this being a 10, so it's saying 10 raised to what power is equal to 10 to the 11th power. because this goes right here. And so, of course, the answer is 11. The answer is 11. And we start to see that because Desmos gives us that answer right here all along. Again, typing this into Desmos, the idea is we want to know that 0.00001 is really 10 to the negative fifth power. And so that means our answer is going to be negative 5. And we've kind of learned the pattern here with logarithms, log function. And but if we were to slide over here to Desmos, and of course you see, yep, that was exactly the answer that we were expecting all along. So here it gets a little trickier. How are you going to type that into Desmos? So when we do that, you're just going to have to kind of get creative in how you make Desmos look like this. They oftentimes, when you're typing into the calculator with your keyboard, you're going to type in 10, then you're going to use the caret. And this is shift 6, kind of a shift 6. And that's how you get this thing right here. And then you're going to type in log5. And so that's how, if you type this into Desmos, you're going to get this little result here. And of course the answer is 5. And that's the thing I want you to notice, is start to notice a pattern. Oh, 10 raised to the log 5, the answer is 5. And you start to wonder, is that a pattern? And of course the answer is yes, because if you change this to a 7, the answer is 7. If you change this to a 9, the answer is 9. So you start to see a beautiful pattern there. So taking the pattern from that previous problem, we see that, oh, okay, so when we had 10 log of 5, the answer was 5. And if we were to say, okay, what about 10 raised to the log of 9? Well, the answer is 9. So it turns out anything raised to the log of a number, that number becomes our answer, right? So really, if we were to say 10 raised to the log of x, well, the answer is going to be x, right? Because we just take that x and put it there, right? And so our question here is 10 raised to the log of x to the 23rd power. Well, since we've learned a pattern down here, so we know that the answer is going to be x to the 23rd. We just learned that whatever is the log is of, that is our answer. So since this is log of x to the 23rd power, we know that that is going to be our answer. And so that's what you're going to have to type in to MyMathLab. And wrapping it up, well, previous 2 slides showed us that 10 raised to the log of a number, we've learned that the answer is that number. So in this case, it's log, the answer is going to be 4. I didn't even bother making a Desmos because we've learned the pattern. And once you've learned the pattern, you don't need Desmos anymore. You just use the pattern and the answer is, in this case, 4.